Hello, my name is Tim Chin. I'm a third year computer engineering student, and I would like to ULA for either CS16 or CS24 over the summer. And I am really excited for this opportunity because I want to give back the knowledge I have learned during my time here at UCSB, interact with faculty more, and I guess just revisit some material. My pronouns are he, him, and his. So without further ado, I'll be doing a quick lecture on the data structure trees. So the tree is a pretty important data structure that consists of a few key components that we essentially need to keep track of. The first thing is the root, which is this right here. It's essentially at the very top of the tree. The next component is the parent node, which is essentially any node that has a child or a branch that extends further down from it. So for example, 9 is a parent, 7 is a parent, 6 is a parent. And the next component we need to keep track of is the child node. So there is the right child, which is 14, 6, 11, and the left child, which is 2, 5, and I guess another 5 over here. So I guess another component of a tree is its depth. So the way we would look at depth is essentially you should visualize each level of the tree by drawing point lines here, this. This. And essentially the depth at the root would be 0, and we increment by 1 each time we go down there. So at the root node, 0, then it goes to 1, then it goes to 2, then it goes to 3. And so for this specific example of tree, the depth would be equal to 3. So the next example of a tree we'll be looking at is the binary search tree, which essentially has a couple of properties. So the properties are that the left child node is always less than the parent node, and the right child node is always greater than the parent node. So the way we would organize this array into this tree data structure is we can start from the 0th element and work our way over to the right. So essentially what we would do is assign 8 as the root element, and we would go from there. So 3 is less than 8, so it goes to the left because left is always less than the parent node. So since 8 would be the parent node of 3, and 3 is less than 8, it would go to the left. 10 would go to the right because of this property here. Then 14 would be to the right of 10, and 13 goes to the left. 14 because it's greater than 8, greater than excuse me, 10, but less than 14, so we go to the left. And 1 be to the left 3 because it's less than 8 and also less than 3, and 6 to the left of 8, but it's greater than 3, so it would be the right child, 3. And 4, since 4 is less than 8, greater than 3, but less than 6, over here. And for 7, since 7 is less than 8, greater than 3, greater than 6, it would then go to the right of 6. So there are also several different ways to traverse this specific tree. 3 of the most common ways is in order traversal, post-order traversal, and pre-order traversal. So an easy way to remember how to essentially apply these traversals is for the in order, you go left child, parent child, you go right child. And then for post order, you would go left child, right child, parent node, and pre-order, go parent node, left child, right child. So using this VST as an example, we would essentially go left child, parent, right. So left child, we go to the very left. So it's 1. Then we go to the parent of 1, which is 3. Then from there onwards, we go to the very left of the right side, 3. So 4. Then the parent of 4, 6. Then 7. Then we take the parent of this subtree here, which is 8. Then we move on to the right side of the tree. So it would be 10, and then 13, then 14. We go 10 because 10 has a left child, so we go back to the parent. Then we go to 13, which is the left child of 14, and then 14 last. Next is the post order traversal, which we go left child, right child, then parent. So I guess the way we would do this is left child first. So 1, then right child 4, 7, then 6, then we go to 3, then we go on to the right side of 8, get 8. So leftmost node 13, 14, then 10, and 8 would be the last element within this traversal. Then for pre-order, we go parent node, left node, and right. So starting from the very first parent node, which is the root, we go 8, then to the very left, 1, then afterwards we do, oh, excuse me for that. It should be 8, then we go 3, then to the left 3 is 1, then 6, then 4, then 7, then we would go 10, 14, and then 13, because it's parent left, then right. So those are the main ways we can traverse through a tree. And essentially, this data structure is pretty important because we can also visualize min heaps and also max heap as trees, which basically states that for a parent node, for min heap, a parent node is less than its children node. For max heap, the parent is greater than child nodes. And I guess that concludes my little lesson on trees. Thank you.